right, so for chapter 10, which we're only going to be going over 10.1 and 10.2, here's the goal, is that we want to see if there's any correlation between categorical data. So far in chapter 4, we looked at if there was any correlation between numerical data. So we could use a scatter plot, things like that. So with categorical data, we're always going to have the same two null and alternative hypotheses. First, the null hypothesis is that two variables are independent. That means they're not related. One doesn't affect the other. The alternative is going to be that the two are dependent. That means that they are correlated. Okay, so our null hypothesis is always that the two variables are independent, so one doesn't affect the other. Now, the assumption is that if two variables are independent, we should see the same proportions in each category. So let's look at this example. So suppose that in a classroom of 100 children, we have 40 boys and 60 girls. When we look at a typical population, what we see is that 80% of people prefer blue and 20% of people prefer yellow. So what we want to see is if the children's gender has any correlation to their favorite color. So what we do is that we go into this classroom and we ask the boys, which one do you prefer, blue or yellow? And we ask the girls, which one do you prefer, blue or yellow? And then we're going to record what they say. So first off, if gender has no relationship with their colors, okay, what would we expect to see in the two-way table? So first off, what this says is it says that 80% of people prefer the color blue. Okay, so if 80% of people prefer the color blue, then what percentage of our boys should prefer the color blue? Well, then 80% of the boys should prefer the color blue. 0.8 times 40, which means out of the 40 boys that we interviewed, we should have 32 that prefer the color blue. All right, if 20% of all people prefer the color yellow, then 20% of our boys should prefer the color yellow. Okay, which would give us 8. Now with girls, again, if we look at the whole population, 80% prefer blue, so that means that 80% of our girls should prefer blue. Oh, whoops, we actually have 60 girls. My apologies. So that should give us 48. And 20% of the girls should prefer the color yellow, which will give us 12. Also, when I add all these numbers up, I'm going to get that total. So 40 boys total, 60 girls total. All right, and then for blue, if I add these together, I'm going to have 32 plus 48, which is going to give me 80, 20 for yellow, so that's going to give me a total of 100 people. Great, now what happens is that if I actually look at my survey, what I see is that I had 35 boys prefer the color blue, not 32, so we're going to be comparing that 35 and 32. I had 5 boys prefer yellow, and I expected to have 8. For girls, I saw 23 prefer the color blue when I should have seen 48. And for yellow, I saw 37 when I should have only seen 12. So here's the deal, is these numbers that I expected versus the numbers I observed, at least for girls, are very far away. So what I think is that I think that maybe gender and color aren't independent, maybe they are dependent. So what we see is that that because these numbers are so far off, maybe girls think that blue is a boy color, so they prefer yellow. Or maybe girls are more likely to think that yellow is a happy color, so they choose yellow over blue. Our second example, what we want to do is we want to see if TV violence is related to physical abuse. So our null hypothesis is that violent behavior and TV are not correlated. Okay, our alternative hypothesis is that these are correlated. So here's how this example is different from the previous one. In the previous example, we had percentages before we actually took our observations. However, in the real world, we're not going to have any information until after we gather our observations and our samples. So here's what we're going to do, is that we're going to look at our sample, and first we're going to think, okay, if my sample reflects a population, then what percentage of our population are going to be abusive? So if I look at people that are physically abusive, which would be this right here, So if I look at this row of physically abusive people, I have 82 people that are physically abusive. Out of, how many people did I look at total? I looked at 329. So what this leads me to believe is that my sample leads me to believe that 24.92% of all people will have abusive behavior. Okay? And remember, when I gathered these totals up, I took them from people that watch high TV or high violence TV and low violence TV. So that means that 24% of the whole population, I think, is going to be abusive. Now, if 24% or 24.92, that's probably more like 25% of the population is abusive, okay? If I look at 66 people, okay, and those 66 people just happen to watch violent TV, then how many people do we expect to be abusive? Well, remember, we're assuming that violent TV and abuse are independent. That means that one doesn't affect the other. So no matter whether we're looking at 66 people who watch violent TV or just 66 people, period, we're going to assume that 24.92% of all people are abusive. So we're going to take that 66 and we're going to find what 24% of that is. So we have to multiply it by 0.2492. And that's going to give us roughly 16.45 people. Now, how does this compare to the actual count? So what we expect is that of our sample, we should see 16.45 people are watching violent TV and are abusive, but what we actually observe, okay, is, yes, physically abusive high violence TV is actually 25. So are those close or are they far away? Well, they're pretty far away. So what we think is that we think that maybe people that watch high violence TV are going to be more likely to be physically abusive, or another way of saying that is that people that are physically abusive are correlated with high violence television. So finding the percentage for each of those and doing that can be a little bit tedious. So what we have is we have a formula. So to get the expected count for a cell, you're going to take the row total times the column total and divide it by the grand total. Okay. So for example, if we wanted to find this expected count right here, okay, where that would come from is we would take 82 times 263 divided by 329, which is the grand total, and that's how we would get that 65.55. Now the rule of thumb is if the observed versus the expected is very different, then we think that the two variables are correlated. If they're very similar, then we have some evidence to show that they are independent. So without knowing the actual math behind this, which we'll learn a little bit later, just going with your gut, do you think that TV violence and real life violence are correlated or not? I think from the expected counts, just because they are so far away from each other, like in the first one right here, 25 versus 16.45, those are about 9 observations apart. And that's quite a big proportion, especially when we're only looking at 25 people. So I would say that they are correlated. All right, so example 3, we're just going to exercise finding expected counts and what our null and alternative hypothesis is. So first off, the two categories we're going to be observing are gender versus opinion on same-sex marriage. So the null hypothesis is that these are not related. Gender versus opinion are independent. Okay, our alternative hypothesis is that they are dependent. So One says that no matter what your gender is, you're going to have similar opinions based on same-sex marriage. The alternative is that there is going to be a difference. Okay, so if we look at this table, what we see is that people's opinions can be strongly agree, neutral, disagree, or strongly agree, or strongly disagree. And you can either be female or male. Okay, so when we look at this, let's first find what is the expected count for those who are female and agree. So we are going to find the expected count for this cell here. So the expected count is going to be, the column total times the row total divided by the gross total. So that's going to be 741 times 423 divided by 1690. Okay, and that's going to give us about 185.47. Okay. Now let's find the expected count for those who are male and strongly disagree. So I'll do this in a different color. So if we're doing males that strongly disagree, remember we're going to take the column total, the row total, and divide it by the grand total. So that is going to be 949 times 327 divided by 1690, which is going to give us about 183.62. Now, when we're doing this, and we actually want to test the hypothesis, what happens is that we have to find the actual versus the observed for every single cell. Okay. After that, we're going to look at the difference between the two, and it's going to look a little bit like standard deviation. So what this is called doing a chi-squared test. So we've done z-tests, we've done t-tests, now we're doing something called a chi-squared test. And chi looks like this, so it's chi-squared test. So the chi-squared statistics, or test, is a statistic that measures the amount that our expected counts differ from our actual counts. So what we're going to do is that we're going to take the observed count minus the expected count, we're going to square it, divide it by the expected count, and we're going to do that for every single cell and then add them together. Okay, so if we do that for the physical abuse versus TV violence, okay, for this first cell, we would take our observed minus our expected, square it, and then divide it by our expected. So we would do that for every single one. So every single cell. And after that, we would add them together, and we would get 7.4. So here's how we can interpret this, is that the further from 0, the less likely the null hypothesis is true. So 7.4 is quite far away from 0, so we have some evidence that this is not true. So the null hypothesis is not true, which means that there's probably a good chance that there is a correlation between physical abuse and watching high TV violence. All right, so I'm going to show you guys how to do this on StatCrunch with the next example because the numbers are ridiculously big. All right, so faculty at Michigan State University and the University of Maryland at College Park created a database of 917 officer-involved fatal shootings in 2015 from more than 650 police departments. Okay, so 55% of the victims were white, and 27% were black, and 19% were Hispanic. For simplicity and lack of data from the Census Bureau, we have removed Hispanics from the data set and have the following frequencies and percentages in the two-way table below. Okay, so what I wanted to show you guys is that during the very beginning of the Black Lives Matter movement, this statistic of 55% of the victims were white and 27% were black was used very heavily to go against the Black Lives Matter. And the argument was, see, there's a higher percentage of white victims, so, you know, they're not targeting black people because there's more white people who are dying. So what we're going to do is we're going to see if race and fatal shootings is actually independent from a statistical lens. So here's the deal, is that in the United States in 2015, per the Census Bureau, white males between the ages of 18 to 64 made up 85.7% of the population. And black males between the ages of 18 to 64 made up 14.3% of the population. Okay, that's only looking at white and black males. Again, we removed Hispanics for simplicity since the Census Bureau didn't have correct numbers or good numbers for that. Now, for the fatal shootings, what we see is that of the 752 fatal shootings that we reported, 504 were white males, which gives us a count of 67% of the ones that we're looking at. Remember, again, we removed Hispanics. And for blacks in fatal shootings, we had 248, which is 33%. Okay. Now, if these two are independent, we should see the same percentage of white males involved in fatal shootings as there are white males in the whole U.S. So we should actually see 85.7% of them. Same thing for black males. Okay, if race and fatal shootings are actually independent, we should only have 14.3% of the fatal shootings being black males and not 33%. So the predicted count is out of the 752, we should see 85.7% of those as white fatalities. So let's look at that. So the predicted count here should be 644.46. So that's 85.7% of the 504. And for the black fatalities, what we should see is that we should only see 14.3% of that 752. So we should only see 107.54. Okay, again, you can get these predicted counts by using the row column times the row total times the column total divided by the grand total. Okay. So, using the totals for the shootings, determine the expected counts for whites fatally shot and for blacks fatally shot, which we did. Okay. Now we want to compare them to the actual counts of fatal shootings and use these numbers to determine if race and fatal shootings seem to be independent or dependent using StatCrunch. So, we're also going to use a significance level of 0.05. So here's how we're going to do that. All right, so when we open up StatCrunch, the first thing that we want to do is that we want to change the above to the names of our rows and columns. Okay. So what we're going to have is groups, white, black, and total. Then for groups, we're going to have ages 18 to 64. And then we're also going to have fatal shootings. We're going to input the observations for each of these. So we're going to have 152, 382, 517, 25446, 631. And for fatal shootings, we're going to have 504, 248. Put the totals in because our software will automatically do that for us. Okay, so after you have your data like this, where you're going to go is you're going to go to Stat, then you're actually going to go to Tables, and what these are called are contingency tables. And we're going to do it with a summary. So when we select the columns, okay, we are going to compare white and black. Okay, for row labels, we're going to hit groups, expected count. Okay, so I want it to give us our expected count as well. So remember, we are looking at the categories white and black. Our labels are by groups. Okay, and we want to look at expected count. So once we hit compute, we are going to get the following table. So I'm just going to go ahead and copy and paste this into our document. So let's see, how does that compare with what we found above? Looks great. It looks like our expected counts are exactly what they should be. Now our p-value is less than 0.001, which means our p-value is less than our significance level. So here's what that means for us, is this means that since our p-value is so low, we can reject H0, meaning there is evidence that shooting fatalities and rape correlated. All right. I've also included this is step-by-step on how to do this with the TV violence example. So if you want to look at that, just remember to get those expected counts if you want to make sure that your work is going well.